The Indian Space Research Organization, better known as ISRO, is the powerhouse behind India's space missions. And yep, that includes their incredible lunar exploration program, the Chandrayaan missions. So far, there have been 3 Chandrayaan missions. The first launched in 2008, and the second followed in 2019. Both were all about getting up close and personal with the moon, studying its surface, digging into its composition, and setting the stage for bigger discoveries. Now the spotlight's on the latest and most exciting chapter yet, Chandrayaan-3. And trust me, you're going to want to hear what this mission has uncovered. But before we blast off into the details, do me a quick favor. Smash that like button and subscribe so you don't miss any of our deep dives into space exploration. August 23rd, 2023, a date that made history. On that day, India pulled off something incredible. With its Chandrayaan-3 mission, it became only the 4th country to land on the moon. And get this, the first to touch down near the moon's south pole, a region no one had explored before. The spacecraft entered lunar orbit on the 5th of August, and India became the first country to touch down near the lunar south pole. At 69 degrees south, the southernmost lunar landing, 12, on the 23rd of August 2023 at 1804 IST, 1233 UTC, ISRO became the first agency to land near the south pole of the moon in its first attempt, and overall the 4th space agency to successfully land on the moon after USSR, NASA, and the CNSA. And what happened next? In just a matter of weeks, India's Vikram lander and Pragyan rover started delivering groundbreaking discoveries from this mysterious, untouched part of the moon. Yeah, this mission wasn't just about landing. It was about unlocking secrets no one's seen before. Chandrayaan-3 had 3 big goals: prove it could land softly and safely on the moon, show that a rover could cruise around up there, and most importantly, run real-time scientific experiments on the moon's surface. Let's talk hardware. The Vikram lander, which made that smooth landing, is a boxy, high-tech beast with 4 sturdy legs and powerful thrusters, each cranking out 800 newtons of thrust. It carried the Pragyan rover and was loaded with scientific gear to analyze the lunar surface on the spot. Then there's Pragyan, a 6-wheeled, 57-pound, 26 kilograms explorer with a mission: to take a bunch of precise measurements to help scientists study the moon's makeup, look for water ice, learn more about ancient lunar impacts, and understand how the moon's atmosphere has changed over time. But the real jaw-dropper? That came just 3 days after Chandrayaan-3 touched down on the moon. That's when the mission's ILSA instrument, short for Instrument for Lunar Seismic Activity, picked up something wild: a possible moonquake. Yep, you heard that right, a moonquake. Think of it like an earthquake, but on the moon. These mysterious tremors have fascinated scientists for decades. The last time we picked up something like this, way back during the Apollo missions in the early 70s. So if this is confirmed, it could be the first moonquake detected in over 50 years. But here's the big question: why does this matter? Why are scientists so hyped about a few shakes on the moon? And even more intriguing, what else did Chandrayaan-3 uncover at the moon's elusive south pole? And finally, here's the kicker. What's the one major thing Chandrayaan-3, just like every mission before it, still couldn't find on the lunar surface? To really understand the weight of these questions, we've got to look at exactly where Chandrayaan-3 landed and why that specific spot could change how we explore the moon forever. All right, let's break down something super cool about the moon that most people don't realize. It has a near side and a far side. The near side is the face of the moon we always see from Earth. It's the one you gaze at during a full moon, and it's also where all human lunar missions have landed so far. Now, the far side, that mysterious half we never see, is hidden because the moon is tidally locked to Earth. That means it rotates at the same speed it orbits us, about every 27.3 days. So we only ever see one face. Only one spacecraft has ever managed a soft landing on the far side, China's Chang'e-4. That's how tricky this stuff is. Now let's talk about Chandrayaan-3, India's game-changing mission. It landed at a spot now officially named Shiv Shakti Point, around 600 kilometers from the moon's south pole. That places it at about 69.3 degrees south and 32.3 degrees east, which means, yes, it's still on the near side, but deep in a region that pushes the limits of lunar exploration. And here's why that landing was anything but easy. First, the terrain. The moon's south pole is rough. We're talking steep slopes, deep craters, sharp ridges, basically a lunar obstacle course. Finding a flat, safe place to land? Not easy. Second, sunlight is scarce. Because of how the moon tilts and the crazy depth of these craters, some areas near the South Pole barely catch any rays. In fact, some haven't seen sunlight in over 1 billion years. That makes solar power, yep, the main energy source for missions, super tricky. And third, the temperature drop is brutal. During the lunar night, it can plunge to minus 230 degrees Celsius or minus 382 degrees Fahrenheit. That kind of cold can wreck electronics and make it nearly impossible to keep instruments functional. Chandrayaan-3 was built to survive just 14 Earth days, one full stretch of lunar daylight. And in that time, it managed to pull off some truly major discoveries. Chandrayaan-3's string of discoveries kicked off with something most people barely think about when it comes to the moon: its atmosphere, or more accurately, it's barely their atmosphere. The moon's air is called an exosphere, and it's so thin, it's practically a vacuum. To put it in perspective, the pressure there is around 0.3 nanopascals. That's roughly 1/trillionth of the air pressure we feel at sea level here on Earth. Yeah, basically nothing. Floating just above this already thin layer is an even more delicate region, the ionosphere. This forms when sunlight energizes atoms in the exosphere, giving us a thin layer of charged particles, or plasma. Here's where things get exciting. Chandrayaan-3's Vikram lander made the very first measurements of both density and temperature in this lunar ionosphere, right near the moon's south pole. What did it find? The layer of plasma, about 100 kilometers thick, is surprisingly sparse, with electron densities ranging from about 5 million to 30 million electrons per cubic meter. And this density changes throughout the lunar day. Why does this matter? Because this plays a big role in radio communication. Denser plasma can slow down radio signals, but since this layer is pretty thin, delays should be minimal. That's great news if we ever plan on setting up human bases on the moon. Smooth communication? Check. And Chandrayaan-3 didn't stop there. It also went below the surface. A special temperature probe with 10 embedded sensors dug about 10 centimeters deep. And what it discovered beneath the lunar dust is just as fascinating. Now here's where things get really interesting. Chandrayaan-3's temperature probe didn't just scratch the surface, it dug in about 8 centimeters deep. And what it found was wild. During the lunar day, the surface of the moon heats up to a scorching 60 degrees Celsius. That's about 140 degrees Fahrenheit. But just a few inches down, the temperature plummets to around -10 degrees Celsius or 14 degrees Fahrenheit. That's a drop of nearly 70 degrees Celsius in less than 3 inches. Crazy, right? This sharp shift tells us something huge. The moon's topsoil or regolith is an excellent thermal insulator. It traps heat, or keeps it out, like a champ. And that could be a game changer. Why? Because if we're planning to build future lunar habitats, places for astronauts to live and work, the moon's soil might actually help protect them, not just from freezing temperatures, but also from the harsh solar radiation that blasts the moon's surface. This little data point, it could be the start of figuring out how we survive long-term on the moon. And guess what? There's even more Chandrayaan-3 uncovered. Let's keep going. Just 3 days after its historic landing, on August 26th, Chandrayaan-3 picked up something no one saw coming: a possible moonquake. Yep, the instrument for lunar seismic activity detected seismic activity beneath the moon's surface. And that's a big deal. But what exactly causes a moonquake? Well, there are 3 main suspects. First, you've got impact events, basically when meteoroids or asteroids slam into the moon, sending shockwaves through the surface. Then, there's the gravitational tug-of-war from Earth and the Sun. That constant pulling and stretching can cause the moon to flex, triggering internal stress and quakes. And finally, there's thermal stress. Huge swings in temperature between day and night can make the moon's surface expand and contract, which sometimes causes it to crack. But here's the twist. Moonquakes aren't like earthquakes. They can last anywhere from a few seconds to a full hour, and they often hit in clusters, not just one isolated event. This latest quake detection? It's unprecedented, and it hints that something deeper, literally, might be going on inside the moon. In fact, some scientists believe they might be seeing signs that the moon is actually shrinking. Yep, kind of like a raisin drying out over time. And if that's true, it could totally change what we know about the moon's internal structure and its future. So here's the deal. The moon is cooling, and as it cools, it's shrinking. Kind of like how a grape turns into a raisin. That shrinking puts serious stress on the inside of the moon. And over time, that stress can create cracks and faults in the crust, which could be exactly what's causing these moonquakes. But there's another theory that's just as fascinating. What if the moon is actually heating up from the inside out? Some scientists think this could be happening because of radioactive elements decaying deep in the moon's core. If that's the case, it could be generating heat, forming pockets of molten rock, aka magma, which might be shaking things up and triggering quakes. Right now, researchers are still digging into the data from Chandrayaan-3 to figure out exactly what caused the quake it picked up. Remember, this is the first moonquake detected in over 50 years, and it might just be the key to unlocking the moon's hidden inner workings. But the surprises didn't stop there. The Pragyan rover had a trick up its sleeve, a high-tech tool called LIBS, Laser-Induced Breakdown Spectrometer. Basically, it shoots a laser at a surface, vaporizes a tiny piece of it into plasma, and then analyzes the light that comes off to figure out what elements are inside. And guess what? It found aluminum, calcium, chromium, iron, manganese, oxygen, titanium, and silicon. Pretty cool, right? But the real shocker? Sulfur. Why is sulfur such a big deal? Well, it ties into one of the most exciting questions about the moon. Does it have water? Here's how it works. In the freezing cold, shadow-covered craters near the moon's poles, water vapor can get cold trapped and frozen into ice. When that ice forms, it can trap other molecules too, including sulfur. Over time, high-energy radiation might break down the water ice, releasing sulfur into the surface. And sulfur isn't just a clue about possible water, it's also a signature of volcanic activity. So finding sulfur? That's a two-for-one discovery. It gives us clues about the moon's geologic past and supports theories about water ice hiding in its darkest corners. So here's something that really got scientists buzzing. No lunar orbiter had ever picked up traces of sulfur at the moon's south pole. That makes Chandrayaan-3's discovery even more intriguing. But while the Vikram lander and Pragyan rover uncovered some groundbreaking data, there was one thing they, and many missions before them, still haven't found: water ice. Back in 2008, India's Chandrayaan-1 made history with its moon mineralogy mapper M3. It detected signs of hydroxyl, basically water-related molecules, in the moon's polar regions. Then, after years of analysis, a 2018 study confirmed 3 distinct signatures of actual water ice on the moon's surface. So what happened? Why didn't Chandrayaan-3 find it? Well, there are 2 likely reasons. First, it might have just been in the wrong place at the wrong time. The 2018 study showed that water ice at the lunar poles is patchy, especially in the south. Most of it is tucked away in the shadows of craters, while the North Pole's ice is more spread out, but thinner. So it's very possible that Vikram landed in a spot where there just wasn't any ice to be found. Second, Chandrayaan-3 itself might have uncovered the real reason. One of its big findings: a sharp drop in temperature just beneath the surface, about 70 degrees Celsius, 126 degrees Fahrenheit, lower only 8 centimeters down. That tells us the moon's soil is a terrible conductor of heat, which means any water ice that survived for billions of years is probably hiding underground, not out in the open. And since Chandrayaan-3 was only designed to last 14 Earth days, 1 lunar daytime, that kind of deep digging wasn't in the cards. Even after the mission window closed, ISRO kept trying to reconnect with Vikram and Pragyan once the long lunar night ended, but no luck. Still, the mission was considered a huge success. It achieved its primary goal: a soft landing on the moon. And during its brief stay, it gathered a treasure trove of valuable data, especially from the resource-rich South Pole, which is fast becoming one of the most important regions in lunar exploration. And India isn't stopping there. Oh, and there was another major update. On August 31st, ISRO released data from Vikram's RAMBHA instrument, which measured plasma density above the moon's surface. Results showed a range between 5 to 30 million electrons per cubic meter, important info for future lunar communications and navigation. The success of Chandrayaan-3 wasn't just a scientific achievement, it became a national moment of pride. Project Director P. Veeramuthuval said it best: "It gives me immense satisfaction. Everything went exactly according to plan." Mission Director S. Mohana Kumar called it a true team effort. Former ISRO Chief K. Sivan, who led the Chandrayaan-2 mission, added, "We've waited 4 years for this moment. It's sweet success for all of us." And leaders across India joined in the celebration. Congress leader Rahul Gandhi praised the mission as a result of tremendous ingenuity and hard work by India's scientific community, noting how far the space program has come since 1962. Delhi Chief Minister Arvind Kejriwal called it a historic milestone, thanking everyone involved and declaring, "It's a proud day for all Indians. Bharat Mata Ki Jai." And with Chandrayaan-4 already on the horizon, one thing's for sure: India's lunar journey is just getting started. The Exploration Museum just made a huge statement by awarding ISRO with the prestigious Leif Erikson Lunar Prize in 2023, honoring the space agency for its unwavering commitment and groundbreaking achievements in lunar exploration. And if that wasn't enough, ISRO's historic Chandrayaan-3 mission earned them the Aviation Week Laureates Award, a major recognition for their incredible accomplishments in space. Shri Priya Ranganathan, the Deputy Ambassador at the Indian Embassy in the US, proudly accepted the award on behalf of ISRO. But the accolades didn't stop there. The team behind Chandrayaan-3 has truly raised the bar for space exploration. In recognition of their game-changing work, they were awarded the 2024 John L. Jack Swigert Jr. Award for Space Exploration. D.C. Manjunath, India's Consul General in the US, accepted the prestigious award at the opening ceremony of the 2024 Space Symposium in Colorado on April 8th. ISRO is clearly on a roll, and the world is watching closely as they continue to push the boundaries of space exploration. The International Astronautical Federation awarded Chandrayaan-3 with the World Space Award. And speaking of world records, get this, Chandrayaan-3's live stream on ISRO's official YouTube channel attracted a jaw-dropping 8 million concurrent viewers. That's the highest ever for a live video on YouTube. Talk about global excitement. But here's where things get even more exciting. Looking ahead, ISRO is gearing up for some seriously ambitious missions. Here's a quick peek. Chandrayaan-4, planned, a sample return mission to bring lunar samples back to Earth. This one's going to require 2 separate launches due to its high mass. According to Narayanan, after the 2 launches, the initial docking of modules will occur in Earth orbit. A propulsion module will then transport the spacecraft to lunar orbit. In the lunar orbit, 4 modules will remain after propulsion module separation, and 2 modules, including the ascending module, will separate and land on Moon. After sample collection, 1 module will return and dock with the remaining modules in lunar orbit. The sample will be transferred to a re-entry module, and the re-entry module will return to Earth with the samples. Chandrayaan-5, approved. This mission will feature advanced lunar rover exploration, with a potential 250-kilogram rover that's set to push the boundaries even further. Space exploration is incredible, but sadly, astronomy isn't taught everywhere it should be. That's why you should hit that subscribe button, so you can stay on top of all the lunar discoveries and space adventures as they happen. Thanks for watching. And don't forget to share this video with other space enthusiasts just like you.